Hi, good afternoon. I want to introduce for you the lab that we are going to talk about today, which is Hooke's Law. And you can see my screen where we have the instructions, we have the submission. This lab is going to be a formal lab report that is going to be submitted together with the Excel sheet that you are going to create. Don't forget to actually access the rubric and see if you did everything correctly. Now, this is the instructions. We are going today to use a FET, which is a simulation, okay, from University of Colorado. And here I'm reading this lab will be a formal lab report. 2 files should be submitted, a Word document and an Excel file. We will study Hooke's law, and we will use Hooke's law to calculate the spring constant that we are going to use. In addition, we are going to understand the relationship between elastic potential energy and the, what is called the displacement or the stretch or compression in the spring. This is the link where you will be able to access the FIT simulations. On operating the program, click on Introduction. Check the following displacement, equilibrium position, and values on the right-hand panel. I will do the following. I will read, and then I will move to the simulation, and then I'm going to move to my Excel sheet. We are going to apply forces of 20 newtons to stretch the spring, and then we are going to record the displacement in the table below. And then we are going to increase the force to 40, and then to 60, to 80, to 100. And we will record the value of the stretch each time. Now we are going to do also the compression. We will compress the spring. Remember, when we compress, the force is going to be to the left. Then its value, I will say you're going to put the force negative, and also the compression is going to be negative. And then we are going to graph. Let me show you what we are going to do. This is the intro part. I checked here displacement, equilibrium position, and values. I can change the force from here. All right. Then every time, like this is the equilibrium where I have 0 force acting, and you can see the displacement here is 0. I can increase the force to first 20. And then record what is the displacement. And then 40. And record the displacement. And then 60, 80, 100. Okay. Also, I will use the compression. And for the compression, I'm going to use the negative 20 as well. Okay, but this number here is going to be negative 0.053 meters. It depends, of course, on your values. Okay, here I will say also that you're going to increase it to the compression to negative 40 till you reach 100. Okay, and then each time you are going to record your values. I will have, this is my force, okay, versus displacement. And then I will show you how I did graph. Okay, let's cut this. Okay, and then here I will choose this, insert, scatter plot. Okay, but just I want to check if I have the correct, like, okay, this is 0.3, then this is the displacement or x, and my y, my force is gonna be on the x-axis. I want the opposite, and therefore I'm gonna do the select data. I'm gonna change this into B and that into A. Either way, like, okay, or what I can do is I can delete that, and then I want to have the x on the x-axis, then this is, I want to delete that, let's say. Either way is going to work. I will choose this, and then I'm going to have this. Now look here, the force is on the vertical and x it's on the horizontal. I will choose my points, and then I'm gonna add the trend line. It should be a linear. I want to display I will say the equation on the graph. Now your slope here is gonna represent your k. Okay, can you see from the equation the coefficient of x is gonna be your slope and is gonna be the value of k. I also want to move this to a new sheet. Okay, I'm gonna call this let's say force versus x graph, something like this. Okay, and then here I will work on the rest, choose the quick layout, the usual work that we are doing. We need to change this into force in newtons, and this one here we want to have that x in, or you can say displacement in meters. I'm gonna again do the trend line thing, and then I'm done from that. Of course, you need to under calculation you need to list the value of your k from the graph. Also, your title here should be different, like it's x is not enough. You're gonna say force versus x graph. All right, now let's move to the second part. For the second for the second part, I'm gonna go to Hooke's law here. I will study the elastic potential energy stored in the spring, and then on the main menu I will go to spring, and then you should find a single spring system, and you're gonna change that to 300. I will show you the K to 300. Don't forget to change it. Now then you are going to click on energy plot and values, enter the values into the displacement box to apply forces and record the force applied and energy below. These are the values that I want you to use. Okay, then you're gonna stick with these values, you should. Okay, then I will go to, you know, this is the second one here. Okay, like maybe you can see it here. Can you see below here? I have the energy 1. Then I have like applied force, displacement, all checked in. And then what I will do is you're gonna change yours into 300, as I said in the instructions, and then you're going to choose the values that I was talking to you about. Like this one should be 0.1. And then you are going to record what is the x, what is the force, and what is really the energy. For example, here 0.1, 30, and 1.5 joules. You're going to change to the next value of like x, and again, okay, like it's not maybe this one, but you're going to stick with the values, find every time the force and I would say the energy, and then you're going to enter these values into your second sheet here. Then I will say this is really my table for my values. Okay. I will now also plot a second graph here. I want to have the energy on the y-axis. Then I'm going to say insert a graph here. Okay. And just I want to be sure what that I have here. Then I will say I can say US versus X graph, something like this, equal. On the x-axis I'm gonna have all the x's. On the y I wanna be sure that I have these values, and then I'm gonna click. I will now move my chart into a new, where I will call that US versus X, and now I have that graph here. I will choose the layout, the quick layout that I like to. Then here I will say this is, you can say elastic potential energy, and that is in joules. And here I will have that as X in meters, and that is US versus X graph. That's okay. Here I'm gonna right click to add the trend line. Is not gonna be it's gonna be polynomial too. It's not gonna be linear. I don't need the equation, but you can have it also. And then there is a question in the instructions asking about plot a graph of elastic potential energy versus extension x-axis on the graph. Allow the scale to go up to 0.7 meters. Use it to predict the value of the elastic potential energy at 0.7 extension. Write your value below. Then this is the value. It is you're gonna calculate it using US equals 1/2 kx squared. This is one value, and the second one, it is from the graph. Okay, then you are going to come to the graph. Let me share the graph with you. I'm gonna look at my 0.7 here. I will suggest maybe doing something like this, having it like, okay, but of course I need to change all my settings here, the trend line, because it did change. Okay, display. I'm gonna get rid of this line here, delete. Wait, why I have that line? Delete that line. Okay, then now here what is my purpose is that I'm gonna say this is 0.7, and then I'm gonna find what is the equivalent here for the energy. Like this is 40, 42, 44, 46, 48 for me. Okay, then at 0.7 I have 48. Then you are going to use your value US equals 1/2 kx squared. You have your x as 0.7, and also you know that your K was 300 newtons per meter. You will calculate what is really the value. Okay, I should have these under the calculation section. Also, you should list the values that I was asking for you to calculate under the results section. For any questions, you can contact me anytime regarding the lab. Thank you and good luck.